Alright, so we're going to go ahead and get started with the Unit 6 Review 2.0. We'll start with number 1. Number 1 was draw a linear, quadratic, and exponential function. So we just had to draw some type of function. So for the linear one, I'll put an L for linear. All you need is a straight line. Any straight line will work here. Next, for the quadratic, since it's a quadratic next, we need to draw a U shape. Note that quadratic is U-shaped. And then the last one, exponential, we'll put an E for exponential. So exponential is going to be a curved line with an asymptote. So it should curve up slowly and have a line that gets really close to an asymptote. So that's question number 1. Now let's move on to question number 2. Question number 2 said, what is the mean of the data set below? So then in this data set, what we need to do is add all the numbers together and divide by how many we have. So in this problem, we have 10 plus 12 plus 15 plus 17 plus 22 plus 25 plus 28. And when we add all those numbers together, we should come up with an answer of 129. From here, we will want to take each number. So we have 1, 2, 3, 4, 5, 6, 7 numbers and divide 129 by 7. So when we do 129 divided by 7, we should come up with our answer, which is going to be a long decimal here. But 129 divided by 7 will give us 18.428571 repeating. And like I said, on the test tomorrow, you will have an answer that will round. So if it asks you to round it, just pay attention to what the question says, and it'll tell you whether to round it to the nearest 10th or 100th or so on and so forth. Now let's go look at number 3. Question number 3 wants to know what the outliers are in the following data set. The easiest way to determine this, there are equations, there are ways to go about it, but the easiest way I found is find the numbers that do not make sense. So when I look at this set of numbers, I see 12, 12, 13, 13, 15, 16, 17, 18, 18, and all of those numbers are relatively close together. But these last two numbers, 29 and 31, are really, really far away from those other numbers. So in this case, I'm going to say that 29 and 31 are my correct answers. And like I said, you can use a formula to find that, but as long as you can look at it, you should be able to identify it on the test tomorrow pretty quickly. So that's number 3. Let's go ahead and move to number 4. Number 4 said if the correlation coefficient between two sets of categorical data is R, represent what R would be for strong positive, strong negative, weak positive, weak negative, and no correlation. So let's just go ahead and write down the numbers that it would be. So for strong positive, and like I said, teachers do this differently. I do it one way. I'm sure Ms. Chandler, Coach Goya, or Mr. Slater does it all different ways. So like I said, it's depending on how your teacher taught it to you. Strong positive just means that it's going to be the numbers from 0.7 all the way to positive 1. Strong negative is when they are negative, so that would be everything from negative 0.7 to negative 1. Weak positive is going to be whenever the numbers are from 0.4 to 0.7. Weak negative is whenever it's from negative 0.4 to negative 0.7. And then no correlation is just simply when it's between the numbers 0.3 and negative 0.3. Perfect no correlation is going to be found at 0. And then perfect strong correlation is going to be found at positive 1. Perfect strong or strong negative correlation will be found at negative 1. So knowing those data points, knowing those points will help you on tomorrow's test. So please make sure you study those and have those memorized for the test tomorrow. Now let's look at question number 5. Question number 5 says draw each of the following. So let's start with normal. So for normal distribution, that's going to be this one here. We're going to have a symmetric set of data. In other words, I like to call it one hump data. It's going to only have one hump in the data set. So when you follow it, it goes up, comes back down. So one hump in the data set. Uniform, which we'll call this one uniform, is going to be whenever the data goes straight across. So that's going to be whenever your histogram or dot plot has data points that are fairly straight all the way across. So when you look at the line, it's going to fall straight across. Skewed left and skewed right, these are my favorite because I think of them as left-tailed and right-tailed. So here with skewed left, we've got left-tailed. So look at it kind of like, I like to say it's an armadillo. Think about it like an armadillo. You have the armadillo's tail. Then you're going to have the body of the armadillo, right? I know, that's weird. So when you look at it, you've got the tail to the left and the armadillo's body to the right. So whenever the tail is to the left, that's what we call skewed left. Skewed right is when it is right-tailed. So on this one, right the opposite, we're going to have the head, the body, and then we're going to come back down and we're going to have our tail going to the right. So tail to the right and then body to the left. So skewed right or right-tailed is going to be the answer for that one. Bimodal is kind of like a camel. If you think about a camel has two humps. So bimodal is whenever we have data that has 1, 2 humps. Bi meaning 2. So for tomorrow's test, please make sure you have all of those memorized. Know the difference in normal, uniform, skewed left, skewed right, and bimodal. There are 2 questions on the test dealing with this, so this is a very important part to remember. Now let's look at question number 6. Question number 6 is a really fun problem, and it's nice because it gives us this chart, but tomorrow on the test you will not have this chart. So if you like the chart, make sure you memorize it before tomorrow. So in the problem, we're given 4 sets of data. We're given 10.1 seconds, 10.2 seconds, 11.1 seconds, and then her final time, which is 13.2 seconds. So we need to write those down. So under data, we're going to write 10.1, 10.2, 11.1, and 13.2. Then we're going to add all these numbers up. So we're going to take all these numbers and add them, and then we're going to divide them by 4. So when we add them up and divide by 4, we should come up with 11.15, and that's going to be the numbers all the way down through here. So we should write 11.15 all the way down for all 4 numbers there. Then we're going to subtract each one of these to get the difference. So when we subtract the top one here, we get negative 1.05. For the next one, we get negative 0.95. Then we get negative 0.05. And then 2.05. The absolute value, that just means to change them all to positive. So that's 1.05, 0.95, 0.05, and then 2.05. Now, for some reason, my chart got shifted. All this stuff that's over here on the left should be over there on the right. So for my sum, I'm just going to add all these numbers up. So when I add all those numbers up, I come up with a sum of 4.1. That is 1, 2, 3, 4 numbers. So I'm going to divide it by the count, which is 4. So 4.1 divided by 4 should give me a final answer of 1.025. Meaning that these numbers are not very far spread out. Actually, they're all really close together. And you can tell by looking at the set of numbers. All right, so that's number 6. Let's now move on to number 7. Number 7, median. If you cannot remember median, then don't take the test tomorrow. It's going to be way too hard for you. Because the best measure of center is simply median. Got it? Good. Let's move on to number 8. Number 8. I actually changed this one, if you recall, in my class. I changed this to compare the median and IQR, which relates more to your test tomorrow. So if you didn't change that in your class, you may want to change it. So here it's very simple. The medians for first period, we'll start with first period. So the median for first period is going to be this number in the middle of your box. And if we follow that down, that's going to be located at 80. So the median for first period is going to be 80. The median for second period, if we look in the middle of the box and follow that number down, it's going to be at 85. So which one is greater? You got it. Second period. So second period has the greater median, and it's greater by 5 points. To find the interquartile range, or the IQR, we just simply need to subtract the third quartile from the first quartile. So the third quartile here looks like it's going to be a little bit past 90, so it's going to be, I'm going to say 92. And I'm going to subtract 75 from it. So 92 minus 75. So when I subtract 92 minus 75, I take that back. Actually, that's going to be 90. So let's go with 90 on this one. Sorry about that. So 90 minus 75, that's going to give me 16. When I look at the quartiles for the second one, the IQR on there, I'm going to once again subtract the first. So now I'm getting closer to 92. There we go. That makes more sense. So that one's going to be 92. And then 90 minus 15. Hold on. 90 minus 75 is not 16. It's 15. Sorry. I keep making mistakes. Driving myself crazy here. So scratch that out. That's 15. Alright, and I may have told you 14 today. It really depends on how you see it. Like I said, you may see this as being right above it. The more I look at it, the more above it is. But like I said, don't get hung up on that. Just know that this one's a little bit wider. Alright, let's go back to IQR here. So we've got, this one was at 92. This one is definitely at 80. So 92 minus 80 is going to be equal to 12. So when we compare these two, we've got 15 on top, 12 on bottom. So which one's larger? You know it, first period. So here we know the greater one is going to be first period. So just know how to find the IQRs. No IQR is going to be the third quartile or the upper quartile minus the first quartile or the lower quartile. That's question number 8. Let's move on to question number 9. Number 9, the first question number 9 asks is, what is the y-intercept? So the y-intercept is located right here. And if you notice, it's right below 80. So for the y-intercept here, let's go ahead and say the y-intercept is 79. Next it says, what does this represent? Read what the side says. Alright, so these numbers are going to represent heart rate, right? Resting heart rate. These numbers represent hours of exercise per week. So if we're looking at the y-intercept, that means he has 0 hours of exercise this week. So when he's did 0 hours of exercise, or he has not exercised at all, his resting heart rate is going to be located up here at 79. So you need to write that out. You need to find a way to write that out. Maybe you say, when the resting heart rate, or when resting his heart rate is at 79 or something like that. Okay. You could also say when the resting heart rate, or the 79 just represents when the resting heart rate has done no exercise. So when his resting heart rate is at 79, that just means that he's done no exercise. Let me add that in there. So when his heart rate, oops, I'm erasing everything. Let me just go ahead and fix all of it. When his resting heart rate is 79, he has done no exercise. So just be able to read that. I don't know if that's necessarily the most important thing you need to know for the test tomorrow, but know how to look at it. Alright, correlation here. Just describing the correlation. All the dots are really close to the line of best fit. So that means this is a strong, and it's going down, so it'd be strong negative correlation. So 3 parts here that we had to answer. Got all 3 parts answered. Part 3 here, part 2 here, and part 1 there. So make sure you know how to identify all 3 parts of the question. Alright, let's move on to number 10. Actually, let's go ahead and end the video here, and then we'll move back to number 10 in the second part of the video.